Okay, so in this video, I'm going to give the solution of 2008 Step 3 Question 6. In this question, P denotes dy by dx, which is saying that P equals dy by dx. And the first question says that given that y equals p squared plus 2xp, show that by differentiating with respect to p, that this equality is true. So the first question, first sub-question of the first question is very simple. It's just to asking us to differentiate this equality and to get this equality. And let's get into it. Y, this is the first question. Y equals p squared plus 2xp, and now we need to differentiate with respect to x, so dy by dx equals so we are differentiating this, which gives us 2p times dp by dx plus 2 times, and it involves product rule here, 2 times p plus x dp by dx. And nextly, dy by dx is equal to p, and after rewrite this equality to p plus x dp by dx, 2 times x by times dp by dx. And nextly, we have negative p equals 2p plus 2x times dp by dx. And reminds here, the question is asking us to have this equality. So the next thing we want to do is to write dp by dx equals negative p over 2p plus 2x, and turn it upside down, we have dx by dp equals negative 2p plus 2x over p, which equals negative 2 minus 2x over p, which is exactly the equality provided by the question. Then hence show that x is equal to negative 2 over 3p plus ap to the negative 2, where p is just an arbitrary constant. So literally we just need to solve this first order what's that called? First order differential equation. And now we arrange it into its general form of a first order dE. 2x divided by p is equal to negative 2. And now because we are doing this with respect to p, and so we now use the method of integrating factor, I times dx by dp plus okay, so x is our mean function, so extract x over here and times 2I over p right here, which equals negative 2. And now I is just e to the integration of 2 over p dp, which is just e to the ln p squared, which is just p squared. And this is not very hard to operate. Maybe you can try this on your own. And now, since we have I equals p squared, we can just substitute into the first order differential equation that we have, which is p squared times p squared times dy by dp, dx by dp plus 2p times x is equal to negative 2p squared. And now we write d by dp, circular bracket, x dxp squared is equal to negative 2p squared, which is just another application of applying product rule into solving a first order differential equation. Now we integrate on both sides. So what we will have is xp squared is equal to integration negative p squared dp, which is literally just equal to negative 2 over 3 p to the cube plus c. And after we write this equation, we will have x is equal to negative 2 over 3 p plus c times p to the negative 2, which is just the equality provided by the question. And it asks us to find y in terms of x if p equals negative 3 when x equals 2. Okay, so we want to find y in terms of x, and if we want to do that, we firstly need to find the value of our a. So we have known that x is equal to negative 2 over 3p plus a p to the negative 2, and now when p is equal to negative 3, x is equal to 2, 2 is equal to negative 2 over 3 times negative 3 plus a times negative 3 to the negative 2, which is just 2 equal to 2 plus c times negative 3 squared divided by 1, which suggests that c is actually equal to 0, which gives us our x is equal to negative 2 over 3p. And we have known that provided by the question, because y is equal to, p squared plus 2xp. P squared plus 2xp, and we want to know about y in terms of x, so we substitute all our p's. So this gives us the p in terms of x, which is negative 3 over 2x, and then all we need to do is just substitute into our y. So we have y is equal to negative 3 over 2x squared plus 2x negative 3 over 2x, which is 9 over 4x squared minus 3x squared, which is equal to negative 3 over 4x squared. And this is our y. Our y is equal to negative 3 over 4x squared. So this is the answer of our first question. Now we move on to the second question. The second question is saying that given instead that y is equal to 2xp plus p ln p, y is equal to 2xp plus p ln p, and that p equals 1 when x equals to negative 1 over 4. Show that x is equal to negative 1 over 2 ln p minus 1 over 4 and find y in terms of x. Okay, so we just need to do exactly the same procedures as the question 1. So we differentiate this y equals 2xp plus p ln p. So dy by dx is just 2p plus 2x dp by dx plus, so we do the product rule on p ln p, which gives us dp by dx ln p plus p times 1 over p times dp by dx, which gives us 2p plus 2x dp by dx plus ln p dp by dx. Ln p, I should put a bracket right there, plus dp by dx, and dy by dx is equal to p. So we will have p plus 2x dp by dx plus dp by dx ln p plus dp by dx is equal to 0, and we extract all dp by dx terms and arrange it just like a first order differential equation. So dp by dx times 2x plus ln p plus 1 is equal to negative p, and we move this term to right hand side, which gives us dp by dx is equal to negative p over 2x plus ln p plus 1. And now we turn the we turn both sides upside down. We will have dx by dp equals negative 2x plus ln p plus 1 over p. It's just the same procedure as what we did in the question 1. It's the same, but it looks a little bit more messy than question 1. And it gives us dx by dp. We move all x to the left hand side and left all p terms on the right hand side. Dx by dp plus 2x divided by p is equal to negative ln p plus 1 over p. And now we do the same, which is integrating factor, multiply a integrating factor on both sides, and I is just e to the exponent of 2 divided by p dp, which is the same, which is p squared. And then we'll have exactly the same, which is dp a d by dp bracket xp squared equals negative p ln p plus, minus p. And we do the integration on both sides, which gives us x to the p, x times p to p squared is equal to integration negative integration p ln p plus p dp. And it gives us negative 1 over 2 p squared minus integration p ln p dp plus a, some constant a. And for this integration, we'll just apply integration by parts to solve this integral, which is u dash is equal to p and v is equal to ln p in order to eliminate all the p terms. So v prime is equal to 1 over p, u is equal to 1. Yes, u is equal to, u is not equal to 1. U is equal to 1 over 2 p squared. The reason why we do the integration by parts in this form is that we can eliminate all ln p's, all the terms that relates to ln function. And after eliminates all of those, we can turn our integrand into a polynomial, which is very easy to solve. So integration p ln p dp is just equal to 1 over 2 p squared ln p minus 1 over 2 integration p dp, which gives us 1 over 2 p squared ln p minus 1 over 4 p squared plus some constant c. So substitute this result of integration back to the equality we have above. We will end up with x p squared is equal to, oh, it's pink, it's not red. X p squared is equal to, firstly, negative 1 over 2 p squared, and then minus 1 over 2 p squared ln p, and then and then plus 1 over 4 p squared plus, and we merge a and c to get some constant c1. Okay, is this correct? Yes, I believe so. I believe that it is correct. And now what we will have is x is equal to negative 1 over 2 minus, we can actually merge this negative 1 over 2 with the constant c1, so we just ignore negative 1 over 2, minus 1 over 2 ln p, and we ignore 1 over 4 right here. Is this correct? Ah, no. Ah, yes. Yes. We have some. Oh, no. Maybe I will just say standard way. Negative 1 over 4 to merge these two constants, and plus c1 over p squared. It can't be we can't merge these two with the constant c1 because p squared is divided right here. So the initial conditions for this differential equation is p equal to 1 when x is equal to negative 1 over 4. So sorry, this should be negative. This should be negative. And sorry, what did I just say? P is equal to 1 when x is equal to negative 1 over 4. P is equal to 1 when x is equal to negative 1 over 4. So we will have negative 1 over 4. Ln 1 is just 0. So negative 1 over 4 is equal to negative 1 over 4 plus c1 over p squared, for which p is equal to 1. So it gives us c1 equals 0. So x is just equal to negative 1 over 2 ln p minus 1 over 4, which is exactly the same that is provided by the question. So and the final goal is to find y in terms of x, which is not very hard as well because we already have the relation between x and p. All we need to do is just to find the p in terms of x, and then to substitute them into the y. So y is equal to 2xp plus p ln p, and we have x is equal to negative 1 over 2 ln p minus 1 over 4. X is equal to negative 1 over 2 ln p minus 1 over 4. And from this, we can immediately have 1 ln p plus 1 over 2 is equal to negative 2x, and ln p is equal to negative 2x minus 1 over 2, and p is equal to e to the negative 2x minus 1 over 2. And right here we have y is equal to 2x times e to the negative 2x minus 1 over 2 plus e to the negative 2x minus 1 over 2 times negative 2x minus 1 over 2, which gives us our final answer as negative 1 over 2 times e to the negative 2x minus 1 over 2. And that is the final answer of our y. And this is the end of this video.